Welcome to February 24th LeetCode Challenge. Sort list. Given the head of a linked list, return the list after sorting it in ascending order. So we're given an array list here, 4, 2, 1, 3. What we want to do is return a list sorted in ascending order. So we're sorting by value will be 1, 2, 3, 4. In this example number 2, we have an array of containing negative numbers and zeros and fives in various orders, and we sort it all out, and it sorts in ascending order because the negative value is on the left side. If we have an empty array called head, therefore we return an empty array as an output as well. Constraints. The number of the nodes in the list range between 0 to 10, 5 times 10 to the 4. Node of the values between negative 10 to the 5 and 10 to the 5. So follow-up question is, can you sort the list in big O n log n time and constant memory, constant space? So if you use basically a sorting algorithm, a sort Python algorithm, the max it would be, hopefully, would be n log n time complexity. As for constant space, we would have to basically just move the pointers around, but probably might not do constant space. I mean, it's possible, but I just couldn't think of one at the moment. So the approach, let's see if we might be able to use. So this is a linked list. Might as well use a list to put all the values in it and then sort it. So basically, create a list, push all the elements of the linked list into the array, sort the array, I should say, and then change the value of the linked list according to the list. That's pretty much the approach. So the first thing I'm going to do is create an array called R. It's going to be an empty one. And then what we're going to do is assign node to be equal to head. Assign node to be head. So while node is not none, what we're going to do is that we could append our node value to our array. Node.val. Alright. And then what we could do is reassign the pointer node to be node.next, and then we just continue this loop. Pretty much putting all the values of node inside the array list. Next thing we want to do is we're going to sort the array. So array.sort. So this function right here is already so this while loop is n log time complexity big O of linear time, so n big O of n. The sorting algorithm itself is n log n time complexity for Python. So that's so far n log n, which is the highest one. And then what we could do is reassign node to be head again. And then what we could do is assign an index so that we can loop or increment our to keep track of our index in our array. So it'll be I equals to 0, and then while node is not none, I should say, while node is not none, what we can do is assign the node.value to be, so we're going to make a new node. We're going to assign the original head to node, and then we're just going to replace all the original array with a different value. So what we can do is array.indexi, then just plug in all the arrays for each value, each index of their value inside the array back into the new node, and then we increment our index by 1, and then we just keep on doing that while loop, and then we reassign node to be node.next. Next. And then what do we want to return? We could return node, or we could just return head, I should say. Let's run this. It might work. Alright, there you go. Let's submit it. So ideally, accepted. So time complexity wise is big O n log n due to the sorting algorithm here. Space complexity, I mean, ideally it is linear time, but we are replacing it with returning a head, which is at most n value. So we're using extra space, as in we're using the array as well. So I'm gonna claim this to be big of linear time or linear space, big of n. So we didn't really meet the criteria, but it is still pretty good though. All right, and that's it. Have yourself a great day, guys.